Okay, so welcome to the Advanced Software Design module, and we are discussing the topic number 7. We have one more topic to cover, which I cover in next week. So today we will focus on the topic number 7, that is management of software maintenance. Now, so far we have been talking about the software design, development, and we came to a place where we focus on looking at software maintenance. Now, when you look at uh, software maintenance, especially, we are going to focus on the management aspect of software maintenance, right? So that is actually a key part of software. And another thing, when you look at the design and development, the most expensive component is considered as a maintenance part. So if you look at um, the cost involved in software development, software analysis, design, coding, and testing. Uh, they all take about like 20%, but 80% of the cost will uh, taken by maintenance aspect. So usually we say about 75 to 80% of system development effort goes to maintenance. So you can see that in management perspective, so it's a crucial part, that's the maintenance. So it is same as the maintenance process you can compare with the system development life cycle, where we have different stages in the maintenance, which you can actually map into development life cycle as well. I'll come to that into a different slide. Now, when we talk about the different types of maintenance, we will talk about corrective maintenance, where we try to correct when there's bugs in the code or bugs in the system. And then sometimes we have adaptive maintenance, where we have to adapt the system for a change, perfective, and also preventive. And then there are different factors affecting this maintenance cost as well. Again, we'll discuss in separately. One is design defect, and the other one is the number of users which uses the software, documentation quality, skill level, tools, and software stuff. So this section we are going to focus on what, how the management process happens, and what are the different types of maintenance, and what are the factors affecting the maintenance cost. Okay, now when we focus on the maintenance process, uh, we start the maintenance coming from the request from user. It could be a bug, it could be a change. And then these changes or the request coming from the user, we need to uh, transform into what we call the changes. Now, when it comes to the changes of the developed software, we have to design and the test the changes, because the changes will affect the overall system. And most of the time, these changes we have to done in the production system, which means earlier when we design the system as fresh or the new software system, we don't really have to worry in the beginning, because we are not actually put the system into act, or we have not deployed it. But when it comes to maintenance, most of the time, the errors and the bugs happen within the production system. So you have to be very careful implementing of the changes. Right. Now, having looked at the maintenance process, let's briefly look at the difference between the standard development life cycle, software development life cycle, and also the maintenance process. Now, one thing we mentioned in early, that maintenance process is also similar to software development life cycle. Now, we know in software development life cycle, usually we start with identify requirements, and then we plan, and then we analyze, we design, and then we implement. Similarly to software development life cycle, in maintenance process, also we have similar stage. So the first stage will be updating maintenance request, and this mainly comes from the user's perspective. And then there will be a maintenance team which are responsible for implementing these changes. Then the next will be the transform these requests into changes, and then you need to design the changes, and then you have to implement the changes. Now, it is only not only that when we have changes comes in, when we look at the overall system maintenance, there are two sides of this. So there will be a customer who reported the bug, and there will be a maintainer who look after these changes. So like in traditionally we have analysis, design, polling, and creating a system. When they have a change, the change made by the user, and then there will be a maintainer who develop this change. So which you should make it effect in the user manual, in the user's perspective. At the same time, those who maintain it, you have to make it in the maintain. So what will happen is from the maintenance side, there'll be answers, fixes, and improvements for customers, questions, problems, and also the session. So there'll be a two-way flow between customers and maintainers. Now, we talk about the different types of maintenance. Now, in short, we will start with what we call the corrective maintenance, which is fixing bugs or errors in the system. Adaptive maintenance, making the program or the software usable in a changed environment. That means we are going to make it adaptive. Perfective maintenance, we improve the functionality based on end user request. Preventive maintenance, we have to perform maintenance to prevent any system problem. So let's go into detail and try to understand what these different types of maintenance are. Now, if we start with the corrective maintenance, uh, now this is the more common one which happens in the maintenance phase, where when we want to start with finding bugs from. So usually there will be a bug reported, and then the request for the maintenance group to fix it. So the fixing the bugs or the errors in the system once they are discovered is what we call corrective maintenance. And this is the most familiar type. So this is top priority, usually corrective maintenance, because without fixing these bugs, you can continue with the software because and it's an error in the system. And usually when you look at the time of maintenance, usually we say it's approximately about the 17% of the time, which takes the maintenance time for fixing these kind of, maintenance aspects. Now, what the skills that you need for the corrective maintenance are is you have to have good diagnostic skills, good testing skills, and good documentation skills. Now that we have understood the corrective maintenance, let's look at the second type. The second type of the maintenance are what we call adaptive maintenance. Now, this is usually comes with the change of the environment. Usually, you develop the software for one system. For example, let's say you develop a software for Windows environment. Now, let's say if you want to make it to work in Mac, for example, Apple operating system, then we can say it's adaptive. Or maybe you can change it to, let's say, Android. So what this means when you want to perform, the change of the environment, we call adaptive maintenance. Now, what happens here is usually you have to freeze a part of new code, and it will be a larger development effort. Sometimes you have to rewrite the whole code depend on the environment that you want to change, because sometimes you have to completely use different tool set to develop this piece of software, which means you have to spend a significant time on development. And usually they say, according to the research, they say about 18% of software maintenance actually comes for adaptive maintenance. Okay, now that we have discussed about the two types of maintenance, corrective and adaptive, let's focus on our third one. So the third maintenance we call perfective maintenance, which is improving software functionality based on end user request. So the goal is we need to improve the effectiveness of the product, and also we need to enhance user experience. So if you focus on what activities happen during perfective maintenance are, you can add additional functionality based on again user request, or you can improve the product itself. For example, you can make the product run faster based on the response time, or you can also improve maintainability of the software. So, uh, so usually they say about like 60% of the time of maintenance goes to perfective maintenance. Last one is preventive maintenance. So that means now we know that there will be a bug coming in, and we want to prevent that. So performing what we call pre-maintenance to prevent any system problems happening in future, which we can call preventive maintenance. Now this is totally different from corrective maintenance, where when you find a bug, you try to fix it. But this is like you maintain the piece of software so that you won't get any bugs in the future, which is what we need really, right? Now, for example, if you are maintaining a car, for example, changing oil and filter, because you want to prevent problems, right? Which will come in later if you do not do that, right? So the goals of preventive maintenance are you can minimize any system downtime, you can enhance system reliability and also the performance, and then you can also reduce likelihood of any future. So as you can see, it's based on what problems you might face in the future. So now that we have discussed the four types of maintenance, let's focus on maintenance cost. Now, our focus of this part is focusing on managing the maintenance, which means when you say managing the maintenance, one of the main thing is the cost. I told you like in the beginning, it's around like 80% of the cost of software development which goes to the maintenance. So what happens is when system age, there will be a time that you know system decrease. So more crucial, and it's also time consuming when system ages, right? That means when you start the system and let's after 10, 15 years time, there will be a lot of time you have to spend on maintenance. So usually we say maintenance costs will increase from 40% to 80% of the budget. So there are factors, some factors affecting these maintenance. One is design defect, and then number of users, documentation quality, skill level, tools, and the software stuff. Okay, let's look at these factors in detail. Okay, let's focus on what factors affecting the maintenance cost. First one is design defect. Now remember that when you ask, develop, let's say, a database management system, you always suggest you to make the design first. You have a conceptual design, then the logical, then the physical. So if you have any errors happen within the, let's say, in your conceptual design, it will take more time to correct it, because the conceptual will affect the logical affect the physical. So you'll see that when there are problems in your original design, you need to spend more time. So more defects increase more time and also effort for identification and fix. So remember that. That's why you should spend considerable time on designing the software system. Then the second one is number of users. Now, when you have large number of user base, then you require more system changes and updates. So there will be sometimes a lot of you know uh, performance issues as well. So the number of users also affects the maintenance cost. Third one, platform. So if you have several platforms, then increase maintenance cost as well. Now when you say platform, it can be different things. Like for example, it could be different software platforms. It could be different hardware platforms. But if you are supporting, let's say, multiple platforms, which means you have to increase maintenance cost. Fourth one. Now, one of the things now we are not focusing nowadays is documentation, but that really matters when it comes to maintenance. So because usually nowadays we have agile world where we will try or focus on rapid development software prototype, and we are not very much focusing on documentation. But remember, this documentation quality affects the maintenance. If you have poor documentation, and this will lead to a lot of searching uh, time for finding us, because sometimes the people will change, and when new people take in, they sometimes do not understand the software code. So proper documentation is always needed, because most of the time you remember that those who develop, right, they might not the one who maintains it. So documentation is very, very important, especially technical documentation. Fifth one, skill level of personnel. Now we know that sometimes when we think about the budget, people might develop system using maybe through interns or maybe using junior software developers and so. But remember, this skill level of personnel is very, very important, because if you are using inexperienced or overloaded programs, it may increase cost, because if you have done a poor job in the development, because you know that there will be a significant difference between the senior developer developing a piece of software as well as junior developer developing a piece of software. So that matters, and that may increase your maintenance cost. Sixth one, tools. You can always use automation tools. Uh, so the automation tools can save a lot of time identifying the problems and also like making the desired solution. Last one, software structure. So remember the software structure again, very important. So well-defined structure and architecture reduce maintenance cost. So having identifying a proper software structure is very, very important, because that will reduce the burden of maintenance. Okay, so what we have discussed here is what factors affecting the maintenance cost. Now let's look at some models for maintenance. When you want to maintain a software, you need some way or some procedure for maintenance. There are many, but when we focus on uh, the reference given for this module, they highlight a model proposed by Harrison, right? So what they say is, uh, when we have a piece of software, and you have to need to make a decision whether you want to modify a particular module or whether you have to rewrite from the beginning. What it means, when there's a bug comes in, sometimes to remove bug, the easiest way is to modify the code. But sometimes modifying a code will take significant time. So in that case, maybe you have to rewrite the module from the beginning. So this is what we need to decide. So rewriting a module is expensive, but if you're just using modifying existing module, and if you have a degraded structure, it may even cost more, or it may cost significant amount of time. Right? So therefore, in case if the modifying a module is not, or it is not feasible, or it consumes a lot of time, the recommendation is you should rewrite. So when we say module is going to have significant maintenance activity, or module A may cost a lot of money, we call it as change tool. So early additional change tool is very important, right? So before you implement, whether the module change, whether it will take more time to fix, identifying it early is very, very important, because then you can allocate maintenance resources effectively. Because otherwise, what will happen? You first try to modify the module, and then you realize that okay, this takes quite a lot of time, and then you have to make a decision on rewriting it from the beginning. So, but if you can identify this early, say that okay, modifying will take a lot of time and cost, then what you could do is you can rewrite directly, which could save time. Again, it's more expensive, but rather than you try to modify and you fail and you are going back to rewrite, so it's better that you start rewriting for the beginning. Right. Now, according to what Harrison and Cook proposed in their model, how you should request non-change for modules. Now, the request means the users will request for any changes. If it not take a lot of time and effort to change, so what you might do is you should analyze, identify the required change. Then you implement the change, and according to the changes, you should also update the documentation. So remember that when you say update the documentation, you have to change user documentation as well as maintenance documentation, which means technical documentation. Then you apply any metric analysis, which are you going to measure the success of implementation, and then you compare with the baseline. That means you have to have, let's say, uh, in your software will take some time to do some particular task, and you know what is the starting value. So after the change, also you can make and you can compare, right? So you have to have some threshold in this particular case, because when you say that the threshold, if it is exceeds, then you have to say that this is change prone, which means it will take considerable time and effort to modify the model. Now the second flow will show you the maintenance request of change prone model, which means that okay, in the beginning you identify that okay, this maintaining a particular piece of software takes a considerable time and effort. So then you can start with identify what is the highest level of artifact effect. Then regenerate the artifact, which means could be the module, and then identify reusable artifact and iterate through the development, and then declare module as non-changeable. So that means if you module or piece of code will take time to make the change. Right. The next point that I want to discuss is how to manage who's going to maintain the code for the software system. So when it comes to maintenance, people actually can debate who should, make the maintenance. Some developers or some companies, they might think, okay, those who have originally developed the piece of code should also maintain the code. So uh, what we what they assume here is, if you are the developer who developed the piece of code, you know about the piece of software or the module, right, in detail, which means the maintenance will be easier. On the other hand, there's another, debate saying that, okay, you better have a separate, maintenance group who work on maintenance tasks. The reason is, the most of the time, those who develop the system, they really don't care about the maintaining the system. They want to keep on implementing new systems. Whereas the maintenance, sometimes it might be time consuming, uh, which might not interesting as like you develop piece of software, right? So as we can see, when it comes to developers maintaining the system, because they are the best, because they understand the system, and then they are better able to make any changes. So if you look at the developer's perspective, often they prefer building a new system rather than maintaining something developed early, right? And one issue for this would be like, usually IT professionals, they think that maintenance is basically fix somebody's mistake. So one suggestion suggested there is, you better have IT personnel in both development and maintenance team. And then you can actually, or change, right? So that means some they can start developing the system, some they can maintain. After some time, they can switch roles. So those who have already developed system, they can work as part of maintenance, and a part of maintenance team can put it as the developer. So the next point is, how do you measure the effectiveness, right? So now the maintenance means you are going to change system. This is based on the particular bug, or this is based on particular product request. So how do you understand, or how do you measure the maintenance process? So you make a change, and how good the change of maintenance is, something that is very important. So during the implementation phase, usually what will happen? There'll be high service requests, bug fixing, and change needs. So properly operating maintenance is very important, and that results decreasing any failure. So remember that. Therefore, maintenance is very, very important. Not only that, you need to record failures, right? Why you need to record? Because if you know that if the frequency is low, that you know that the system performs better, right? So we can identify and resolve problems if decreasing failures is not noticed. Next one is, you can also look at the time between the failures and as a measure of success. So what it means, let's say it will take longer time between failures. So that means you have more time, or you can have more focus on improving the system. As a last point, we have to note the recording the type of failure is very, very important. Why? Because it helps understand how failure occurs, and you can avoid them in the future as well. So the recording is very, very important. And the second point is, it enables development solutions that address root causes of various failures, because that stage may address a lot of other failures as well, right? So recording the type of failure is very important. Now, as a last point, let's discuss how to control the maintenance request. Now, I told you there's a process of change in request. So these change requests come from the user, and usually the change request comes from the user, and then there will be a project manager which actually submits the request to priority board, which they will check whether the request state is valid and also aligned with the system goals and so on. And then you get the decision. So once you get the decision, then the project manager assign this to a program, right? And then the manager also inform the user about the decision, right? So as you can see, we need some methodological handling of problems and change request is essential. So usually systematic flow of requests is managed by IT departments, and there will be approval process and prioritization of requests because you might not be able to address everything you will get. And approval process and prioritization requests should come from various ways. And here there are like different people work on the process, mainly the project managers. They can categorize and they can pass requests to priority. Next, priority board determines if the request is aligned with the business model and assign priority. And the decision are communicated back to the project manager for action. And then what happens? Project manager reports the decision to the user and implements changes based on the priority. A few things you have to consider. First one, type and severity of change in plus priority. So which means important changes may receive immediate action. Batch changes for multiple changes in a single month. So import ones, they will you know get immediate attention. Next, you can queue of changes as a valuable tool for controlling work. So, for example, high priority items receive immediate attention, then low priority items may be impacted by changing needs or new system solution. Right. Okay. So that's all what I have about the system maintenance, especially managing or maintaining software systems. So let's conclude what we have covered in today's session. So we discussed about what we call the system maintenance, and we discussed the idea of the importance of system maintenance and also error-free and as a categorized as a successful system. So proper management is very important. So if you use proper management of maintenance, it saves a lot of time and money. And third one, well managed maintenance department meet the needs of users. Right. So that's all what I have about the topic for today, that is management of software maintenance. So since we have covered, let me go back to what we have covered so far in the syllabus. Right. So what we have covered so far, we talk about the interaction software development cycle, the life cycle as a first topic. Second, we have discussed user-oriented system and outsourcing decisions. Third, we discussed software development approach, different approaches we have discussed. And then we discussed development before the fact technology. That means the use of getting facts and also drawing primitive structures based on F-maps and T-maps. Then we also focus on software engineering design. You have already done this in another course, but This is for recap. Last time we discussed EBP auditing, and today we discuss management of software maintenance. Right. So the last topic what we have is cost estimation in software engineering, which we are going to use different cost estimation methods available in software engineering. With that topic, we will almost cover the topics of uh, advanced software design. Okay, guys. Uh, so I'll finish for today then. Let me check whether we can have the attendance system. If that is okay, looks it's working. Okay, let me share. Please mark the attendance. If you have finished marking the attendance,